Hello and welcome to this video on the rules of implication 2. This is section 7.2 in our textbook. In this video we're going to introduce 4 more rules of implication. They are to be used in the same exact way that we used the first 4 rules. Those were the rules of implication 1, used in order to derive conclusions or to deduce conclusions. Let me start with the first one, which is constructive dilemma. So what I'm going to do is I'm going to give you an example from language, from content, and then I'll show you what this would look like when it is formalized as a rule. So here it is. If Pedro goes to Stanford, then he has to move to Palo Alto. But if he goes to a community college, then he can stay home. Pedro must either go to Stanford or go to a community college. Therefore, Pedro must either move to Palo Alto or stay home. Okay, so that is the argument. There's a conclusion there. There are premises. Let's now look to see what those are in greater detail. So let us symbolize these with letters. Remember that we are using lowercase letters. And the reason for that is because these are to be thought of as variables. The P, Q, and R and the S here are to be thought of as variables. The reason why they are to be thought of as variables is because, remember, this form is going to apply to any argument. And so it basically means that it's universalizable to any argument. So P can represent Pedro goes to Stanford. Q can represent that he has to move to Palo Alto. R, that he goes to community college. And S, that he stays home. So if we allow those letters to symbolize, if we let those letters symbolize those propositions, then the symbolized argument will look like this. If P, then Q, and if R, then S, that's the first premise. The second premise is P or R, and then the conclusion is Q or S. So notice that we have it now symbolized as a rule. Let me get rid of these little squigglies here. Okay, let me go back to that. We now have it symbolized or formalized as a rule, and it is right here. If P, then Q, and if R, then S. P or R, therefore Q or S. So remember what that means. If we ever see these two premises in some form, when we look at the proofs, we're actually going to see them in capital letters, right? Not as variables. We're going to see them as actual representations of real propositions, right? And so we're going to see eventually when we look at a proof, we'll see some premises that look like this, like that basically that have this form. And if we do, then we can conclude Q or S, right? And now that might be what we're trying to ultimately prove, but it could also be just a step in the proof. But either way, this is the rule. This is how it's formalized, and hopefully it makes sense logically why we would have, why it works logically, as I've shown you in terms of content. Okay, so the next one is conjunction. Conjunction is a little bit more easy. Let me straighten this out a little bit. Okay, here we go. Conjunction is a little bit more easy, and it's abbreviated CONJ. I have all the abbreviations here in the parentheses. Okay, so conjunction. Let's suppose that P represents John goes to UCLA. Let's suppose that Q represents John gets a part-time job. So then if we have P, and that's what we have here formalized, and we have Q, then what conjunction basically says that given P and given Q, we can conclude P and Q. Okay, so the question now is, why is that? Why is it that we can conclude that, and why is it that this would be valid? Remember, these are all valid forms, including constructive dilemma. So why is it that this would be a valid move? Well, remember that in a valid argument, if the premises are assumed to be true, the conclusion must necessarily follow. And when we are asserting these premises, we basically are assuming them to be true. So if it is true that John goes to UCLA, and it is true that John gets a part-time job, then it would necessarily follow that John goes to UCLA and that John gets a part-time job. So the conjunction would follow if those two premises are true. And that's why this would be a valid form. Okay, so that's conjunction. Let's go to our next one, which is simplification. And that's abbreviated SIMP. Okay, so let's look at the complex statement here in terms of language. First, let's do that. Frances plays volleyball her freshman year, but she also studies in Spain her freshman year. Her first semester, I mean. Let me read that one more time. Frances plays volleyball her freshman year, but she also studies in Spain her first semester. Okay, so notice that the word but is really a way to conjoin these two, right? I could have also written Frances plays volleyball her freshman year, and she also studies Spain in her first semester. Remember that in regular language, different words can be used for conjunction, so keep that in mind. Okay, well, if we symbolize this, we let P represent Frances plays volleyball her freshman year. We let Q represent Frances studies Spain her first semester. Then what this is saying is that if we have the conjunction, Frances plays volleyball her freshman year, and Frances studies in Spain her first semester, or if we want to express it in terms of the but, if we have the conjunction Frances plays volleyball her freshman year, but she also studies in Spain her first semester, then the conclusion would follow that Frances plays volleyball her freshman year, right? So if it's true, again, remember we assume the premise here. In this case, we only have one premise. We only have the conjunction as a premise, right? Remember, whatever's above the line is a premise. So if we have that premise that Frances plays volleyball her freshman year, but she also studies in Spain her first semester. If we have that premise, and that premise is a conjunction, then we could basically extract out the P. Basically, if that premise is true, then it would also follow, or it would be true, or it will necessarily follow that Frances plays volleyball her freshman year. And that's why simplification is valid if we assume the conjunction to be true, which, remember, that means that both statements have to be true in order for the whole conjunction to be true, right? The P and the Q have to be true in order for the whole thing to be true. Then it necessarily follow that one of its conjuncts is true. So P would be true. Okay, so that's simplification. Next we have addition, and our last rule here is addition. So suppose that we have John gets accepted into Princeton, and that is represented by P. And suppose that we have John walks on the moon, and that's represented by Q. Okay, what addition basically says is that if P is true, which again, remember, we're assuming it to be true, it's a premise, it's above the line there, that if P is true, you could add anything to it with the disjunction. So that's why we have the or operator there. We could add anything to it. As long as that P is true, the whole thing is true. Remember that disjunction has this criterion that at least one of its disjuncts has to be true in order for the whole disjunction to be true. So that's what's going on here. If the P is true, which again we're assuming it to be true, if we're trying to find out if the argument is valid, we have to assume it to be true. And so if we assume that P is true, then the whole disjunction would have to be true, right? At least one is true. In this case, the P is true. Then the whole disjunction would have to be true. And so that also means that we could add anything to that P. And as long as that P is true, as long as it's true that John gets accepted into Princeton, then anything can be added. So we could add really crazy things here, like let's add a different one. Let's add R, and if P is true, then P or R will also be true, because remember we have that criterion there of at least one being true. So if R represents dinosaurs dance at night, then that would follow. That P or R would follow. And again, the point here is that anything can be added, and that's because anything can be added, and that's because if we assume that first P to be true, that first disjunct to be true, the whole thing is automatically true. So that allows us to add anything, even if it's something totally crazy like dinosaurs dance at night. Okay, that is it for this video on the second 4 rules of implication. So again, remember that the point here is that we're going to use these in order to prove certain conclusions in the very same way that we use them in section 7.1. So we're going to be doing the same thing. And I will, of course, give you examples of that. In fact, the next video is going to be examples on proofs, on how to work with these rules in terms of proofs.